In this video, we're going to solve triangles involving the ambiguous case with law of sines. This is where you're given the measure of two sides and a non-included angle, and we don't necessarily know right off the bat without testing if a triangle can be formed with that kind of information, or maybe there's one possible triangle or two possible triangles. So this is the ambiguous case. Now, I have a chart here that summarizes the process to figure out for these ambiguous case problems if there's 0, 1, or 2 possible triangles. I have also made a separate video where it shows why this is the case using geometry, where I use a protractor and a compass to kind of show visually why with some of these characteristics, comparing the opposite and the adjacent side, why there could be 0 triangle, 1 triangle, or 2 possible triangles. And so if you need to, you can go find that video, check it out, and maybe that would help. And so I have one example for each case here that we're going to work through, and so that way we can kind of see what's going on. Now, I'm looking here at this first question, and the goal is to sit here and figure out, all right, is this a possible triangle? And if it is there more than one possible triangle, or do I need to worry about finding 2? Now, the process is, I'm a visual person, so I'm going to draw a triangle. I always put the given angle on the bottom left. So I got angle B here. And we know its opposite side is 20 and adjacent side is 17. I also make my unknown side always down here on the bottom. And then so I have my adjacent side, which is 17, and my opposite side, which is 20. Now obviously it's not drawn to scale here, but so I get this triangle. And I don't know, I'm gonna come up with an angle here at the top, call it C. Now, looking at this, because we have 2 sides and a non-included angle, because the 45 is not the angle formed by the 2 known sides. And since the opposite side is bigger than the adjacent, so opposite side and the adjacent side here, so opposite side is greater than the adjacent, there is only one possible triangle that can be formed. All right, so if there's only one possible triangle that can be formed, it's got to be the one that is the way I drew it. So I'm just going to finish solving this problem using law of sines, where I say, okay, well, let's go find the other information. So we can say sine of 45 divided by 20 is equal to, now we'd have to go solve for A next, because we have its opposite side of 17. So equals sine of A divided by 17. And then I work my way to finish the solve there and say, okay, well, that means sine of A is equal to 17 times sine of 45 divided by 20. And then we would do inverse sine of that right-hand side. And I don't have a whole lot of room to write, so I'm just going to type in and say 17 sine of 45 divided by 20 is 0.601. And I'm going to do inverse sine of that. So second sine, second answer. And we get the measure of angle A to be 36.94. All right, so the measure of angle A is 36.94. And last thing left is find the measure of angle C. Well, angle C here, we got the other 2 angles. So C is going to equal 180 minus 45 minus 36.94. And we'll get the measure of angle C. It'd be 98.06. All right, so there's one possible triangle. You continue to solve it like just you would for any other law of sines scenario. Now let's go here and let's look at the second problem that I have. All right, so this one we're given the measure of angle C. All right, so angle C I'm going to put here on the bottom left. And I don't have, this is going to be my unknown side on the bottom. The adjacent side to it is 28. And the opposite side is 5. So this is 70. Obviously not drawing the scale. And I want the side opposite of it to be 5, which means that this has got to be angle B. And we'll call this up here angle A. Now, looking at this scenario, I look and compare opposite to adjacent sides. So the opposite side of the known angle is smaller than the adjacent. So anytime that happens for this side-side angle scenario, so opposite is less than adjacent, we got to test for possible triangles. All right, so I have to test for possible triangles. The test is I got to find the altitude. So the altitude is going to go from the angle up top to the measure of the unknown side, and I call that H. All right, so H, and when I do this, to find the H, I'm looking at basically this right triangle here, and I'm going to highlight here in blue, where I have the 70-degree angle, opposite side H, hypotenuse 28. So that means sine of 70 equals H divided by 28, opposite over hypotenuse. So H is going to equal 28 times sine of 70. And that's going to give me, so 28 times sine of 70, 26.311. Now, what this number is, so 26.311 is the minimum length required. For the opposite side. So I needed to have 26.331 or greater for an opposite side. However, we only have 5. So my 5, it's not long enough. Which means no triangle can be formed. So our answer here would be no possible triangles. So there's nothing to solve for because I can't make a triangle. That opposite side was too small. All right, so we got a case where the opposite side was bigger than the adjacent, which means one possible triangle. And the second one, opposite was smaller than the adjacent, but that opposite side was too small, so no triangle can be formed. So I guess we all know what's coming next here in this next one. So in this next problem here, we're given the measure of an angle A that's 43 degrees. All right, so angle A, 43 degrees. So I'll draw it like I did all the other ones. So 43, unknown side on the bottom, opposite side of A, 27. Adjacent side is 28. All right, so the adjacent side was C, so that's angle C. This is angle B. All right, so opposite side smaller than adjacent. So opposite side, adjacent side. I only got to do this test for two sides of a not included angle. So opposite smaller than adjacent. So I have to test for triangles. All right, so the test is find the altitude. So I'm pulling altitude down from B. It's the angle at the top. I cut the unknown side. I call this H. So the altitude, I'm looking at the right triangle here. So you have 43 opposite H, hypotenuse 28. So I'd use sine. So H is going to equal 28 times sine of 43. So 28 sine of 43 gives me 19.1. So that's my minimum length required. Well, we got 27. So since 27 is greater than the minimum length required, we actually have two possible triangles here. Now, the possible triangles is going to be based on the angle C over here. Now, if you always draw your triangles the way I do, it'll be on the bottom right. So C, angle C, is the ambiguous angle. Now, what I do with this information, all right, so if angle C is the ambiguous angle, that means we have two cases. So case one is the triangle is exactly the way I drew it, where angle C is located to the right of the altitude, making angle C acute. And so case one is C is acute. Now, if it's acute, I'm drawing the triangle, or using the triangle exactly the way it's already drawn, right there on the left-hand side. So I'm not going to redraw it for this part. I'm just going to refer to it and say, okay, well, let's solve for the other, all the other information. Well, we know that we have sine of 43 divided by its opposite side of 27 is equal to sine of angle C divided by 28. So I'd go find C. So angle C is going to equal inverse sine of 28 times sine of 43 divided by 27. And so that's going to give me acute angle C. So 28 sine of 43 divided by 27. Inverse sine of that. And so acute angle C is about 45.01. All right, so that's acute angle C. Now that I have acute angle C, let's go find side B, or angle B and side B. So angle B at this point is going to equal 180 minus 43 minus acute angle C, 45.01. So 180 minus 43 minus 45.01. So 91.99 degrees is angle B for this case when C is acute. Last thing left is to find side B. So I'd go back to law of sines and say, all right, sine of 43 divided by, let's see, divided by 27 equals, and then I would use my angle B here, so sine of 91.99 divided by side B, which we don't know. And so I'd cross multiply and divide here, and I'm just going to write out what it would be. So I'd cross multiply and divide in my head. So it would be 27 times sine of 91.99 degrees. And then I would have to divide the sine of 43 off to B. So divided by sine of 43 degrees. And so that would give me side B. So 27 sine 91.99 divided by sine of 43, 39.57. Is the measure of side B. Well, so far, it just seems like a standard problem. All right, nothing really changed. Well, here's the part that is different. So we just solved the case that if this angle C was acute. Well, now we have to account for, well, what if angle C was obtuse? Well, obtuse angle C. So case 2 over here is C is obtuse, which means that it would have fallen to the left-hand side of that altitude. All right, and so I'll do my best to try to draw that picture, so that way we can see what would happen here and what it would look like. So we have angle A that we're given, and we had this unknown side here. And then we have the 43-degree angle. We have 28. All right, and so I'm going to make this a little bigger. The altitude that we drew here was H. So this here is H. It's not part of the triangle, but just that way you can see. Acute angle A fell to the right-hand side of that altitude. It fell somewhere over here. But angle C. Obtuse angle C is going to fall somewhere on this left-hand side of that altitude. Now that altitude was the 90, but now what's happening is angle C is going to be right here and puts angle B up top. So the triangle that I'm looking at solving here is that one that's there in black. And so to solve this, what we would do is your first step is to find obtuse C. So obtuse angle C is going to equal. Now, because we're talking about a limitation for the sine function, remember sine has its same values on the unit circle as it does in quadrant 1 and quadrant 2. So I want to find that quadrant 2 angle, that obtuse angle, where sine has the same value. So I take 180 degrees, and I'm going to subtract acute angle C, which we got to be 45.01. So I'm subtracting acute angle C. So minus 45.01 degrees. And this is going to be the obtuse angle that we're going to use for C. And so C in this case, if C was obtuse, would be 180 minus 45.01. And so we get 134.99 degrees. Now, just to remind you, the y, so pay attention to the calculator over here on the left-hand side. So if I did sine of 134.99, I get 0.707 roughly. I should get the same decimal if I did sine of 45.01. I get this exact same decimal. This is why it's a limitation for law of sine, is because it's ambiguous case. We have the potential to have the first angle that we have to solve for in this problem, where it could be obtuse, and we have to know if that's a possibility or not. So that's the why we're having to do all this madness. Okay, so now we know what obtuse angle C is, and I forgot to write angle A, or excuse me, side A up here, which is 27. So now that we know what obtuse angle C is, we didn't have to do law of sines to find it. We just subtracted it from 180. We'll go find angle B. So if angle C is obtuse, angle B is going to equal 180, because the sum of the three angles in the triangle equals 180, minus 43, minus 134.99. So the measure of new angle B here, it's going to be tiny, 180 minus 43 minus 134.99. It is only 2.01 degrees. So we have new angle B. Last thing is to get new side B. Well, I'm going to use my given measure, my unrounded version. So sine of 43 divided by 27, so 43 degrees divided by 27, is going to equal, so I got to find side B. So sine of 2.01 degrees divided by side B. Now side B is that one right here. And we'd cross multiply. So B and then we divide. So b is equal to 27 sine of 2.01 divided by sine of 43. And that's going to give us what side b is. So I'm expecting to be pretty tiny. So 27 sine of 2.01 divided by sine of 43. And it's very tiny, 1.39. Okay, so this is the ambiguous case. And we have one example for each of one possible triangle, 0 possible triangles, or 2 possible triangles.